All right, today we're going to dive deep, and I mean really deep, beneath the waves. We're going to explore one of the most breathtaking and, honestly, vital ecosystems on the entire planet, coral reefs. And these aren't just pretty rocks or some kind of underwater plant. No, they're vast, living cities, and they're built by the tiniest architects you can imagine over millions and millions of years. A world painted by dreams. I mean, how perfect is that? It just, it perfectly captures the kind of magic we're about to get into. We're talking about places of almost unimaginable beauty. They're truly underwater kingdoms. So here's how we're going to tackle this. To really get our heads around these incredible structures, we're going to go on a bit of a journey. We'll start big, looking at their massive scale. Then we're going to zoom all the way in, like microscopically in, to meet the builders. And then we'll pull all the way back out to see just how huge their impact is on the entire world. Okay, so let's start with the big picture, that massive scale. When you think of a coral reef, I want you to picture an ancient, sprawling civilization. It's this incredible tapestry of life, just flourishing in the warm, sunlit parts of our oceans. And I mean, think about this for a second. We're talking about structures so massive, so unbelievably big, that you can actually see them from space. The Great Barrier Reef is a perfect example. In the wild part, it's all built by these tiny, tiny organisms, creatures smaller than the head of a pin. It's a mind-blowing testament to the patient, relentless power of nature, right? So the big question is, who is this master builder? Who's behind these colossal creations? Well, let's zoom way in and meet the little guy responsible. Say hello to the coral polyp. It's a pretty simple, soft-bodied animal, kind of like a tiny cousin to a jellyfish. But don't let its size fool you. This is the fundamental building block of every single coral reef on the planet. This is it. So how does something so small build something so big? Well, the process is actually pretty straightforward, but really powerful. It all starts when one single polyp finds a nice spot, like a rock, and settles down. First, it builds itself a little limestone cup for protection. Then it just divides. It makes identical copies of itself, and the new polyps build their own homes right on top of the limestone skeletons of their ancestors. You repeat that process generation after generation for millions of years, and boom, you get the massive, intricate structures we see today. But here's the twist. The polyp isn't working alone. It has a secret weapon, a hidden partner that's absolutely crucial. It's a microscopic engine that provides almost all the energy it needs to build this incredible empire. Living right inside the coral's own tissue are millions and millions of these tiny golden algae. They're called zooxanthellae. It's a mouthful, I know, but just remember this. They are the true power source of the entire reef. And the partnership they have is just perfect. It's one of nature's best deals. The algae, they soak up the sunlight, use photosynthesis to make food, and then they share a huge chunk of it, up to 90%, with the coral. And what does the coral do in return? It gives the algae a safe place to live. It's evolutionary genius. One of the most efficient and brilliant partnerships you'll find anywhere. So here's the key takeaway. This tiny, microscopic relationship is the reason for two of the reef's most famous features. First, why they need sunlight? Well, it's for the algae. And second, those spectacular, vibrant colors, that's the algae too. They literally paint the reef from the inside out. Okay, so now that we know the secret, let's zoom back out. Because this amazing partnership, it doesn't just build a structure, it fuels an entire ecosystem. It creates a bustling, vibrant metropolis just teeming with life. Now, I'm about to give you two numbers, and I want you to really let them sink in, because the contrast is staggering. Okay, first number. All the coral reefs in the entire world, they cover less than 1% of the ocean floor. Less than 1%. That is a tiny, tiny sliver of our planet. Okay, but now for the second number. That tiny 1% provides a home for 25% of all marine species. A full quarter. The amount of life, the biodiversity packed into these ecosystems, it's just completely off the charts. It's incredible. I mean, for the animals that live there, the reef is everything. It's a safe nursery for baby fish. It's a hunting ground for big predators. It's a shelter from the rough and tumble of the open ocean. It truly is, in every sense of the word, a living city. All right, let's zoom out one more time, even further. Because the reef's influence doesn't stop at the water's edge. It actually stretches onto land and plays a critical and often totally unseen role in protecting us. Think about this. When a massive storm or a hurricane comes rolling in from the sea, the reef acts like a giant natural shield. It's a breakwater that absorbs a staggering 97% of the wave's energy. It just breaks it apart before it can slam into the coast. And this isn't just some nice little feature. We're talking about 500 million people. 500 million people all around the globe who live near a reef and depend on this silent guardian for their safety, for the protection of their homes, their towns, their lives. So we have this ancient, powerful, life-giving system. But here's where the story takes a turn. For all its strength and importance, this legacy is incredibly fragile. It's like an ancient witness to history that is now facing threats it's never seen before. The biggest threat, the one you hear about most, is something called coral bleaching. And here's what that means. When the water gets too warm, the coral gets stressed out. And what does it do? It kicks out its partner, those little algae we talked about. And since the algae give the coral its color, without them, it turns a ghostly bone white. Now, it's not dead, not yet, but it's lost its main food source. It's literally starving. And if things don't get better, it will die. And just to put into perspective what we stand to lose, some of the massive corals that are alive today started growing more than 4,000 years ago. Think about that. They were already ancient when the Great Pyramids of Giza were being built. These aren't just animals. They are living history. They are witnesses to thousands of years of our planet's story. So that leaves us with a pretty big question, doesn't it? These ancient, life-giving structures, they're sending out a warning signal. You can see it in their fading colors. They are fragile witnesses to our rapidly changing world. And the real question is, how are we going to answer them?